Matibay. Hello, grade 7 learners. Welcome to our lesson on sets. Today, we'll explore what sets are, how to describe them, and why they're important in mathematics and everyday life. By the end of this lesson, you will be able to describe and identify sets and their elements. Identify different types of sets: finite, infinite, empty, and universal set. Express sets using description and roster methods. Let's start with a quick activity. Grab a notebook and pen. List items that are visible at home and in school. Write your answers in the circles and pause the video. Okay? Grab your notebook. With your answers, I want you to answer these questions. What groups did you identify? What are the items in each group? Are the items distinct from each other? Pause the video. At home, we have beds, tables, and refrigerators. To name a few, you may have living room, you have sofa or couch, television, coffee table, curtains, lamp, wall clock, picture frame. Bathroom, you have sink, toilet, shower, bathtub, towels, soap and shampoo. And for kitchen, you have dining table and chairs, refrigerator, stove or oven, plates and utensils, cups and glasses, pots and pans. And for the bedroom, you have your bed, pillows and blankets, wardrobe or closet, mirror, side table, and alarm clock. And how about the items visible at school? You have these classroom essentials: chairs, desks, whiteboard or blackboard, chalk or markers, bulletin board. And for the learning materials, you have books, notebooks, pens and pencils, modules, charts and posters, computers, worksheets. And for facilities and equipments, you have lockers, trash bins, fans or air conditioners, projector, laboratory tools. And then other visible items owned by the students: school bags, water bottles, uniform, ID cards, handy fan. Okay, so these are examples of sets in real life. The groupings, how they are grouped, it's just like sets. Okay, so sets in real life settings. Sets help us organize these things. For example, arranging clothes, organizing school materials, or managing club memberships. We can use track categories like science, fiction, book, or art club members. What is a set? A set is a collection of well defined, distinct objects. The objects contained in the set are called elements. What do you mean by well defined? Okay, let's have these examples. The set of odd numbers between 5 and 15. So, what are the elements found in this set? So, you may begin with 7, 9, 11, and 13. So, these four elements are all odd numbers between 5 and 15. And how about a not well defined set? Let's say the set of pretty ladies in grade 7. This is not well defined because when say pretty, it is subjective. Now, let's try this activity. Identify whether each of the following sets is well defined or not. Put a check mark if it is well defined, and cross mark if it is not. Grab your notebook and write your answer in your notebook. Let's have number 1. The set of local government officials. Number 2, the set of odd numbers between 1 and 10. Number 3, the set of Philippine presidents. 4, the set of months containing 31 days. 5, the set of cities in Metro Manila. The set of prime numbers below 100. The set of letters in the word matatag. And the set of planets with the moon. The set of entertaining magicians. And the set of shops with aromatic coffee. I want you to pause the video and then answer these 10 questions. Okay, let's check your answers. Okay, let us check your answers. Here are the well-defined sets. The set of local government officials, the set of odd numbers between 1 and 10, the set of Philippine presidents, the set of months containing 31 days, the set of cities in Metro Manila, the set of prime numbers below 100, the set of letters in the word matatag, and the set of planets with a moon. These eight, these questions, these items in number 1 to 8 are facts, Bayesian facts, while 9 and 10 are not well defined. The set of entertaining magicians, this is very subjective. A magician, you might be not entertaining, or for some, they are very entertaining. Set of shops with aromatic coffee. So we have different tastes. Okay, so let's proceed. Sets notation is used in mathematics to essentially list numbers, objects, or outcomes. Set notations uses curly brackets, or we call this braces, which are sometimes referred to braces. Objects placed within the brackets are called the elements of a set and do not have to be in any specific order. Sets are named using capital letters, with some sets having predefined names like N for natural numbers and W for whole numbers. Here are the examples of sets. A is the set of prime numbers less than 10 with the elements 2, 3, 5, 7. B is the set of letters in the word brain. We have BRAIN. Again, elements may not have specific order. C is the set of primary colors. We have blue, red, yellow. D is the set of counting or natural numbers. So we may begin with 1, 2, 3, 4, and so on and so forth. And S is the set of perfect squares less than 100. So it may start with 0, 1, 4, 9, 16, 25, 36, 49, 64, and 81. So, so we use curly braces for sets. And there are two basic methods to describe a set. First, we have the verbal description method. The set is described in words using a verbal statement. Second, we have roster or listing method. The elements of the set are listed in a row, separated using commas, and enclosed with braces. So examples of sets written using the verbal description method. The set of colors in the Philippine flag, the set of odd numbers less than 10, and the set of grade 7 subjects in the Matatag curriculum. Okay, let's give examples of set written using the roster or listing method based on the examples in verbal description method. So first, we have the set of colors in the Philippine flag. So in roster or listing method, we have blue, yellow, red, and white. And for number 2, we have the set of odd numbers less than 10. So we have 1, 3, 5, 7, 9. And for number 3, the set of grade 7 subjects in the Matatag curriculum. So we have math, science, English, Filipino, AP, MAPE, ESP, and TLE. At this point, I want you to answer activity 2. Describe these sets using the roster method given the verbal description. Let's have number 1. Set A contains the surname of the women presidents of the Republic of the Philippines. Number 2, set B contains the surnames of male classmates born in the month of December. And 3, set C contains even integers between 10 and 20. Pause the video and answer the question. Okay, let's check your answer in activity number 2. For number 1, so the women presidents of the Republic of the Philippines. So first, we have Corazon Coangco Aquino and Gloria Macapagal Arroyo. And for number 2, I have in my one of in Samuel Einstein. Okay, this school year. So these are the male students whose birthday fall in the month of December. So we have Boris, Sondanero, and Maluluyon. For number three, we have this even integers between 10 and 20. So we begin with 12, 14, 16, and 8. Okay, now let us first, let's have the types of sets. First, we have the finite set. The elements are limited. Second, we have infinite set. Elements are unlimited. Next, we have empty or null set. No elements at all. And then last, the universal set. All elements in a context. Let's have examples of finite sets. The set of planets in the solar system. And S is a set of 5, 10, 15, 20, and 25. So these are multiples of 5 less than 30. And number 3, the set of letters of the word mathematics. So we have MATHEIC and S. Examples of infinite sets. So we have the set of points in the number line. They are infinite. It's unlimited because you can extend the line in both directions. Number 2, the set of whole numbers. It never ends. Some even has trillion pesos. People, if you notice people there, we are never contented. We always aim for the higher, bigger, or even the biggest. The set of odd numbers. So we begin with 1, 3, 5, and so on. And examples of empty sets. The set of all unicorns that exist in the real world. When we're younger, we believe that there are really unicorns and they're very cute. And then now we realize that unicorns doesn't exist. And then number 2, the set of even prime numbers greater than 2. So when you say even, it has only 2 factors, 1 and itself. And then next to 2 would be 4. So it has 1 and 4, 2 times 2. If you have 6, you have 1 and 6, 2 times 3. So there's none. There is no such even prime numbers greater than 2. Then next, number 3, the set of black hearts in a standard deck of playing cards. So of course, heart should be red because there's blood in it. And it symbolizes love. So we use braces or the symbol like this to denote an empty set. Okay, and examples of universal sets. The set of all countries in the globe. So it in Asia, Africa, Antarctica. You need to name them all. And the set of all provinces in the Philippines from Luzon, Visayas, and Mindanao. And the set of students enrolled in our school this year. So from grade 7 to grade 12 if you have senior high. We usually use the capital letter U to denote a universal set. So if you notice, we use the word all in our examples. Now let us answer activity 3. Grab your notebook and pen and identify each of the following sets as finite, infinite, empty, or universal. Let's have number 1, the set of whole numbers less than 20. Number 2, this set A has 0, 1, 1, 2, 3, 5, 8. 3, the set of letters in the English alphabet. 4, C with the elements 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 5, the set of vowels in the word rhythm. 6, the set of all barangays in the Philippines. 7, the set of all junior high schools in the country. 8, the set of mobile phone brands in the world. 9, E is the set of Ken, Josh, Pablo, Justin, Stel. And 10, the set of vegetables mentioned in the Filipino song by Kubo. Post the video and answer the items. Now let's check your answer. Number 1, the set of whole numbers less than 20, that will be finite. So we have 0, 1, 2, 3, 4, 5 until unity. So that's limited. Number 2, it's infinite. So your clue is there is an ellipsis here. Okay, it never ends. Number 3, the set of letters in the English alphabet. So from vowels and consonants, so there are 26 of them. It's countable. The number 4, C, although there are ellipses, but it ends until 100. So there are only 10 elements. So you have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It's gone. Number 5, the set of vowels in the word rhythm. Is there a vowels in the word rhythm? There's none. So there's no elements at all. Number 6, the set of all barangays in the Philippines. All the barangays from Luzon to Mindanao. That's universal set. And 7, the set of all junior high schools in the country. So your clue class, there are all, the word all in the item. That's universal set. Number 8, the set of mobile phone brands in the world. Although there are a lot, this year there are new, you have Techno. Before we only have Nokia, but now there are a lot. But still, it's countable. It's finite. Number 9, we have Ken, Josh, Pablo, Justin. Are you familiar with them? So they are present. They are my favorite boy band or boy group. They're SB19. So it is finite. And the last, the set of vegetable mentioned in the Filipino song, although there are a lot, but it's still countable. It's fine. Now let's next we have cardinality of a set. Cardinality of a set means the number of elements in a set. It can be finite or infinite. For example, the cardinality of set A with the elements blue, yellow, red, and white. So the colors in the Philippine flag is equals to 4. So in symbol, we say n of A is equals to 4. N refers to number of the elements in the set. And in this case, we name the set as capital A. So n of A is equals to 4. Another example, the cardinality of set B. So we have 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. These are the odd numbers less than 20. So if you count them all, there are 10. So in symbol, we say n of B is equals to 10. So if we always use the name of the set in capital letters. Next, we have the cardinality of set C is equal to 2, 4, 6, 8, 10, 12. And here comes the ellipsis. So this set is an infinite. So in symbol, we say n of C is equals to infinity. So infinite. Now, let's have activity 4. Grab your notebook and pen and answer the following questions. Find the cardinality of each set. Number 1, set M has the elements 100, 200, 300, 400, 500, 600, and 700. Number 2, the set of prime numbers p that are greater than 1 but less than 50. And number 3, set D has the elements 3, 6, 9, 12 until 24. Pause the video and answer the question. Let's check your answers. Number 1, N of M is equals to 7. Number 2, N of P is equals to 6 with the elements 2, 3, 5, 7, 11, and 13. And number 3, we have N of D is equals to 8 with the elements 3, 6, 9, 12, 15, 18, 21, and 20. These are the multiples of 3 less than 20. And that brings us to the end of our exploration into sets, the building blocks of mathematical thinking. We've uncovered how sets help us organize elements, classify them into types like finite, infinite, equal, and null, and measure their size through cardinality. Whether you're solving problems or structuring data, understanding sets gives you a powerful tool to think clearly and logically. Keep practicing, stay curious, and remember, in the universe of mathematics, everything starts with a well defined set. Thanks for joining me. Until next time, keep learning and keep growing.